featuring Jaime, the CEO of Codacy, talking about code review and how you can integrate it and how it can supplement continuous integration practices. Very big thank you to Constant Contact for hosting us tonight, providing the wonderful pizza and the environment and everything for us to have this meetup. Yeah, round of applause. Yeah. So for those of you attending for the first time, a little bit about this meetup. We started it just over a year ago, formally on Meetup.com. We, at Solana Labs, we were doing some ad hoc gatherings talking about continuous integration and automated testing. And a lot of people that were interested in it said that we should make it into a formal thing. So we started about a year ago on Meetup.com. We've been going strong ever since. We now have over 400 people registered in the group. So it's doing really well. We also have other meetups around the country, Seattle, Boston, New York. So it's really a cross-country event. So at this time, I'd like to welcome up Anthony to speak a little bit about Constant Contact and tell us a little bit about them. And thank you for hosting us.
No worries. Welcome to Constant Contact. My name is Anthony Akita, Software Development Manager for the social team here in San Francisco. Here in San Francisco, we focus mostly on social media and mobile applications. Constant Contact as a whole, as some of you may have heard of us, focuses on email marketing. Slowly pivoting on how we market to small businesses right now, however, that's our main focus. We're always after talent, so if you're interested in looking for a job right now, if you've got a resume you'd like to submit, by all means, just stop by and see me. We also have jobs advertised on our website. Someone was asking about our stack. We run pretty much a hybrid stack right now of Ruby and Java applications. Most of our front-end applications run Ruby stack with a Java backend service API. We also focus on a lot of JavaScript technologies in the front end, jQuery, Marionette, Backbone. So they're also the skills that we are looking for. If there's any other questions, by all means, just stop by and ask, and I'll be able to answer those questions for you. Otherwise, I'll hand you over.
Great, awesome. So first of all, thank you so much for Solana Labs for the opportunity. Thank you so much for Constant Contact for the hosting and the amazing space for us to talk. I'm Jaime. Right there is Paul. We're both from Europe. Codacy is a European company. And we're the founders of Codacy. Codacy is an automated code review solution that focuses a lot on uses this static code analysis as a principle to do whatever. A lot of things that we do. Everyone in the team is in love with code, so this is why it's exciting to be talking to you today. So today we're talking about static code analysis. And the first thing that we should ask is, why do we care about static code analysis? There's several reasons. First of all, the world is expected to spend $1 trillion by next year in managing and paying back technical debt. The perfect metaphor for technical debt is if you're cooking for friends at home and like it's amazing time, then they leave and you have like a kitchen filled with dirty dishes. You have a lot of options. One is you clean. If you're really good, you can make your friends clean them for you. But the problem is that if you don't clean them right away, the next day you wake up, you're gonna make breakfast, oatmeal's gonna be amazing, and then you'll see that you have crust. The grease turned into crust and all of that. The kitchen now looks like a nightmare to clean. If you don't act upon that, and so you wait like 2 weeks, you procrastinate cleaning your kitchen, the cost of buying a new kitchen sounds very appealing to you. This is essentially like technical debt. So every time we make stuff, we push stuff, we take shortcuts. Even if we're very good, there's always some kind of shortcut there. And if we don't pay back this, it will lead up to being a huge thing that we have to just, let's just start again. So this is technical debt in very limited terms. Why does static analysis matter? Because it's one of the components that make you pay or make you be actionable against technical debt. So you have, for instance, continuous integration, which is like one of the most important things you can have for managing technical debt, managing quality. You of course STP, code review is a big component in static analysis. So static analysis, if in very brief explanation, is the process of trying to find issues and bugs, looking at code, not running it, and trying to understand what it does to say, hey, on line 34 you have a problem, you should be using this keyword or this variable is not used. And so why we think it's important is because we're not getting enough of it. Static analysis tends to be seen as like a null thing, like people used to use it in the 90s. But the thing is, we think it shouldn't be used by itself, it should be used with a purpose. For instance, how many of you do or interact with pull requests on a daily basis? Okay, awesome. So how do you, for instance, review code style in those pull requests? I would have to guess probably manually, or like say, hey, variable foo on line 42 is not in camel case 2. Come on, this is Java, or this is root. So this is, for instance, one excellent example of how you could put tools working for us, saying, hey, I don't even want to look at your code, I have better things to do. And so let me just put this tool working in the technical code for you and not really worry about code style. I have other things to review, such as design patterns, such as architecture, such as best decisions in terms of putting code in places. So we think that static analysis should be put to work for us to save us time. There are other use cases. For instance, you're onboarding new developer. You don't have time to explain the best practices, the common errors, the code style. So what do? You put a static analysis tool saying, hey, just do what the tool tells you to do. Don't even submit a pull request if you have issues. If you're outsourcing code, you can put the tool working for you to say, hey, this code has issues. And I don't know if you've seen it, but it has issues, right? To increase overall code quality, this is just a bunch of use cases. So we really believe that the tools used properly and configured, especially with their CI, really save time. So what's this talk about? So what I'm going to cover is 15 tools, 15 open source free tools that you can use today. Most of you probably already use it in some way. But what's interesting is whenever we watch another programming language, is what tools do they use and why they use it. So for us, it was interesting to just do a survey of all the tools because we do it anyway for Codacy. And so we thought this was interesting for everyone, especially how they compare against each other, right? So in the end, we're doing a final comparison of all the tools and see which language is better. So the idea is to really compare these tools. We're going to do a very simple rating. For each of these 4 points, we're going to rate them from 1 to 5. This is, of course, a very basic notion. It's a little bit subjective as well, but we try to take into consideration several data. For instance, for activity, when was the last commit? Was it hours ago, a day ago, a week ago, a month ago, a year ago? Why is this important? Because we, as users of tools like this, we need to be certain that a week from now, or like a year from now, this tool is going to be supported. It doesn't going to break whenever a new version of Ruby comes up. It's going to be still relevant. So activity in developing the tool is very important. Popularity. So is the tool actually being used by a lot of people? Do they have Stack Overflow questions? Or is there a lot of forks or stars in GitHub? It means that people are pushing the tool, people are using it probably. So popularity is kind of like another way to see it. Quality and number of checks. So do they have security checks? Is it only best practices? Is it only code style? Is it like an overall picture that is like all in one box? And of course, future plans. What is the next idea? Is it extendable from my checks? So I have a check that I wanted to put in this tool. Can I put it? So like, is this tool be better and awesome and different in a year from now? So all of these are essentially the ratings that we try to put on these tools. So what we try to do is for JavaScript, PHP, Python, Ruby, and Scala, we're going to ask you questions. So first of all, which are the static code analysis tools that exist for this language? We're going to, of course, limit these by 3 tools per language because we didn't have more time. What's the grade using the rating for each one? And we're going to be very minimalist and try to answer which one should you use. Of course, this is completely subjective. We most probably are taking opinions on this, but sometimes we just have to do it. So let's just jump to JavaScript. So JavaScript, we'll talk about JSHint, ESLint, and Skip.js. So JSHint, some history on that tool. Originally for JavaScript, there was a tool called JSLint, which was designed by JavaScript god Douglas Crockford. And he said, JavaScript is a beautiful language, but inside JavaScript there's a beautiful language, but outside JavaScript is really slow. So he designed the whole set of tools to really bring out the inner beauty of JavaScript by saying you should have to write JavaScript this way. What happened was that a lot of people, especially like top developers, tried to use it really inside their workflows, and they come up with, what, it's so pedantic. So whenever if I fail a white space online, whatever, and then I have a security issue and JSON would catch it, it would fail. It will not find a security issue because it would fail previously. It would essentially say the tool would say essentially, well, I'm not saying anything else, just go fix this one job. And people said, this is too pedantic. So let's try to create a tool set that's community driven, and that's while opinionated, it's not that, that doesn't have that dictatorship of rules and results. So this was JSON. It has hundreds of collaborators, thousands of stars in GitHub, and regarding, for instance, some of the key components, it's just a great tool. It has, last activity was a few hours ago, there was a commit. It's really popular, there's a lot of questions, people are using it. It's completely integrated with most IDEs and tools. Regarding quality and number of checks, it ranges from code style to error-prone issues. It just is a very well-rounded tool. The only issue, of course, is that the way it's designed, the tool, is the checks and the parsing mechanisms to understand what the code is doing to analyze it. So essentially, the abstracts and tree construction, the parsing mechanisms are really coupled together. So essentially, if you want to extend the tool and add your own checks, you can't. Or well, you can, but it will have spent a week doing so because it's really tied together. And this brings to the second tool, which is ESLint. ESLint said, JSLint is amazing, but I want to add my tools. How can I do it? So they designed the whole system where they decoupled the checking, so the code analysis checks from the parsing mechanisms. So by decoupling this, they've made checks pluggable. So you can develop your own code checks if you want, like variable names and different types of styles. You just plug it in. And so essentially in terms of activity, very active, popular, not as popular as JSLint right now, at least from when we took in, of course, but I truly believe that in terms of popularity, it will really grow because I think it's kind of the future. And the number of checks, there are a lot of checks, maybe even more than JSLint, but they're not as mature as JSLint provides right now. JSLint has 3 years on it, ESLint is a little bit more novice. But in terms of future plans, I mean, any one of us can write a check for that, which is really interesting. And there's finally another tool.
Yeah, good question. It sounds like they could put a JSLint hint on top of ESLint. Couldn't you take the tools from hint and put them into ESLint?
Could you repeat the question?
So the question was, it sounds like they could put JSHint on top of ESLint. Most certainly, I think so. So they can build JSHint with ESLint. That's the question. Yeah, most definitely. I think actually one of the main purposes of ESLint at the beginning was trying to do that, emulate JSHint perfectly. But yeah, so they have been early on, so it's an early project, but they have a website. It's already very exciting. First I analysis tool, it's already nice. So yeah, very good question. The last tool for JavaScript.
If they decouple the parsing from analysis, what do they do with the storage? Could you repeat that? What do they do with the storage?
Storage of results, storage of storage. How storage? What do you mean?
if they parse first and then analyze, I assume in the meantime they save the data somewhere, right?
Of course. Well, the whole idea is like in terms of design of the software, they made like one component not dependent on the other. There's not like communication of data between these two. It's not like services. It's just like the code is one place and the checks are in another. So whenever you want to change a check, a check, you just go to this place and don't even have to bother with the whole parsing mechanism, which is not the same thing as JSN. So if you want to add a check in JSN, you really have to dig down into the parsing and really search for it, and it's hard.
It is clear that they are decoupled. You say that clear. What is not clear is where do they store after they parse? Do they put it in memory or do they store it in memory?
Yeah,
it's in memory.
Yeah, sorry, yeah, it's in memory. Yeah. So last tool for JavaScript is Scat.js. It's essentially a very security driven, very security focused type of tool. The purpose, it's Mozilla behind it, so you know it's must be good. And the idea is really to target down security issues. So some of the security issues that they have quickly, it's for instance storage information. If you are using an API to store information in your browser, pops up something that, hey, you shouldn't be using that. If you're using user-sensitive APIs as well, it pops up information. So it's a tool designed for security of the browser itself when you're designing JavaScript programs. But again, it's not as big, of course, as the previous ones. It's not as popular as well because especially JS is huge. And it's really targeted to security issues. Because it has Mozilla, we thought, well, it still has a great company behind it, so it will continue to be supported for some time. So, essentially with JavaScript, this is, of course, recommendation that we do for ourselves, so take this, of course, with a grain of salt, but we believe that you should use JSN. But if you feel curious about it, you can start studying ESLint because I think it will be really, really cool in a couple of months or maybe next year. Moving to PHP. So for PHP, the first one is Code Sniffer. Code Sniffer is essentially one of the standards for static analysis for PHP. All of the standards like PSR, Peer, Zend, all of them are integrated there, and so it's very configurable. You can just put it in and say, hey, I want the PSR2, which is one of the standards for PHP that you have available. It's extremely configurable. It's very interesting in terms of the results it provides. It ranges from error-prone code to best practices to code style. It's just a good tool if you want to have this for PHP. In terms of activities, very active. Have commits just this few days, I think. Popularity is, comparing to, of course, what JSLint is. It's big, not as big as it could be, because we found out, or at least our sense, that the PHP is very fragmented. So you either want to have testing and then you have static analysis, or you don't care and you just want to, use SVN and you say file and push to master. So that's the type of things that we've seen. So it's not as big as the previous tools. Regarding code quality road checks, it's also a pretty good tool. Not that many feature files for that. Now, if we drill down, we have PHP Depend, which is a tool that was inspired by JDepend. I don't know if anyone has used it, which is a tool that finds high-level type of analysis. So you can select maintainability, reusability of code. Instead of drilling down to issues, they can tell you, hey, this code is not maintainable, this code is not reusable, this code is not extendable. So it's like a high-level kind of analysis. It's very interesting though. It's not as active or not as popular as the previous one, but still, it's a pretty solid tool that you can use. The next one was inspired by this previous tool, PHP, and it's not as active as the previous one as well, but it provides more metrics, different than the one the previous tool provided. So the idea is also the same idea, so providing like maintainability, reusability, extensibility, and instead of going to other stuff. And use parameters, map properties, complicated code, complexity. So, in our opinion, CodeCipher could be a great candidate if you want metrics and if you like to create dashboards. This is actually what you use to create dashboards in Codacy. Both tools are actually to show like, hey, look at your code. PHP is a mess right now. It's PHP mess detector says so. And you can use that to create nice dashboards. Actually, some of these tools actually export HTML, so you can create like routines to export HTML and show it in a nice dashboard if you want. Jumping to Python. Of course, yeah.
I saw the screenshot you showed of the code sniffer
Yeah.
that it links JavaScript and CSS, or what's the story on that? What is that?
It tokenizes as well JavaScript and CSS, yeah. So it
So
tokenizes,
what
yeah.
are the standards it's using for those?
So it also does some sort of JavaScript and CSS analysis, but we consider that those analyses are as deep or as interesting as the other two. So for instance, for CSS, we have CSS lit,
Okay.
which is a humongous tool,
Yeah.
very, very cool tool with lots of different analysis. What we really like about CodeSniffer is not the rest of we actually filter down the rest of the JavaScript and CSS. You can configure to turn those off and not see any of those. For Codacy, we filter all of those out because we just want the PHP out.
Okay.
For CSS, just a curious fact, we have CSS Lint, which is a very good tool as well, community-driven in JavaScript we already talked about, but yeah.
Is it JS Lint or JS Lint?
I don't think it's using CS. I don't think it's using any of those. I think it must use No, thank you. Jump into Python. So Python, we believe, from what we've seen, of course, that there's a clear separation between PyLint and the rest. So PyLint is really great. It provides very good type of analysis, like error detection, checking unused variables. It has amazing integrations with IDEs and other tools and CIs, of course. It enforces code standards such as the Pepe designed by Guido, the creator of the language. It's fully customizable. This is something that you see also in JS Hint, which is a file that you put on your source code and say, hey, just turn on the things that I like to see. Turn on just detect these couple of checks. And this has also support for configuration files. So it's just very good. And it just casts shadows on the rest of it, to be honest, because this is just an excellent tool. It's shipped with distributions. So Pep8 is actually the code style that Guido designed, the creator of the language. But around that code style, there was some open source tools coming in, like with the same name, saying, "Hey, we enforce the code style designed for Python." The problem is that none of them are like the standard. The biggest one has like 1,000 stars, 1,000 stars on GitHub, but hasn't been developed for I think 6 months or since May or something. So it's not really active. And so, in our opinion, it's really just better to go back to PyLint. Just interesting, of course, to check because PyLint is already most of these stuff. There's also, of course, another one called PyFlakes, but this one is even less active than the previous one. Doesn't have any future plans for development, and it hasn't seen any updates relevant. It's a couple of months. Still a very interesting tool, of course, because every single tool brings something else, something more to the ecosystem. So this is, of course, interesting. Use PyLint. This is what we think. Maybe I think the best solution. This is what we use for Codacy to analyze Python code. For Ruby, first off, I have to say that Ruby has a very unique community of developers because we find that no one else cares about code testing and code quality as Ruby developers. You see that tools are just a little bit better. You see that testing is just a little bit thought out. You see that TDD was actually created because of Ruby people. It's just interesting. And developers, Ruby developers, Rails developers care a little bit more about their testing water quality than the rest of us.
Why do you think is that?
Well, I have my opinion. I think it's a dynamic language. I think the language is
The language is crap.
well, that's a very strong opinion. I wouldn't say the language is crap. I think the language is pretty damn interesting. I also think that the Ruby developers tend to be very good as well. So that's a whole very interesting conversation that we have to probably talk about afterwards. So the first one is Googlecom. I think it's an amazing tool. It has, it's very active, it's very popular, it has an amazing number of checks, and the checks are really good as well. The checks are so good that if you want the tool to correct the issues that it finds, you can correct the issue that it finds. And they have future plans for it. So the tool is just like, it's the only find that we gave, because we really truly believe that this is the way to go in terms of building not only a community-driven tool, but also maintaining it and using it and doing documentation. The documentation is amazing. We love Googlecom. We currently in Codacy don't support Ruby or Rails yet. We're working on it, but we truly believe that this is something that if I have to start a Ruby project tomorrow, I go to this. So overall, it's just a great tool. For Rails specific, you have Rails best practice, which enforces best practices, code style, enforces community-driven decisions surrounding how code should be organized. Again, as I learned, Googlecom is so good that it kind of casts a shadow between everything else. So in terms of activity, it's not that active as Googlecom. Googlecom has commits, I think hours ago, the last time I checked, of course. It's not as popular as Googlecom as well. So it's a good tool, and you should definitely check it if you're passionate about this. But Googlecom is the thing. Now, we decided to add a code coverage tool here as well, for one reason. Is that code coverage is such a big element. It's not really static analysis, but code coverage is such a big element of Ruby software development. Doing testing, continuous integration is such like ingrained with developing Ruby and Rails code that we truly believe this tool needs to be mentioned. Referring to a website that lists all of these tools, I think the popularity of Simple Code was like twice as much as Googlecom, and that should say something. Code coverage is just something that is pervasive and it's used by Ruby people. So again, activity, very active, of course, very used, very useful as well. It's a popular tool as well. People love it, like to use it. Code coverage is something they're like, hey, I don't have code coverage for Ruby. Help, give me something. And the only issue is that it's very targeted, of course, for code coverage, so we won't find anything else. It's fine. It just does what it tells you to do. And then it doesn't. They're not planning to expand this anything else, but it's just a good tool for code coverage. Then you shouldn't expect anything else out of it. So what we say is, at least for Ruby, is you should definitely use Googlecom, and you should definitely use Simple Code, because those tools are essentially a very big component of Ruby development. You could, to tie this together, of course, you can use continuous integration solution, which can integrate a lot of these aspects, but we can talk more about it afterwards. If you're still very bored, we can talk about Scala. This is Python language. So for Scala, which is a very new, by the way, any Scala developers here? Okay, so probably it's not a Haskell, really? Awesome. Okay. That's it.
Which is better.
Well, okay. Language wars. Okay. So Scala. So the first thing is, again, we see this, and if you look at this, you see a pattern, right? So you have one that is like best, the one that is second, or like it's not as good, and then you have like another alternative. So it's kind of like there's the same thing. So this is the JS hint, if you want, of Scala. This is the yes lint of Scala, and this is the one right now supported by the whole Scala development community. The guys behind Scala, I wonder, so the people behind Scala are developing their own static analysis, and so this one is the one that probably we should all bet. But these three are actually excellent. So yeah. As a fun fact, everything in Codacy is built in Scala. We really like the language. So in summary, this is essentially like a breakdown. If we use this grid, now we can do cool charts with it. You can see that, for instance, JavaScript has JS hint, JS lint, very cool. The biggest achiever, of course, Googlecom from Ruby. And if you add these up together, you get a nice sense of going in that direction of language wars that you're going after. You can see, like, for instance, JavaScript and Ruby have a very good testing practice or static analysis practice. And then you can see that PHP, Python don't. Of course, all these languages are excellent for different reasons, but the testing and static analysis are, different. Of course, this is the consideration or subjective rating of the code analysis mechanism behind it. But if we take a simplistic view, at least we can do full charts with it. Just a very small, and just wrapping up, just a very small thing. If you wanted to pick up some of these and run it automatically, every commit, this is what we do. So we just essentially, like, for almost all the languages that we talked about, except Ruby, we run all of these together, we organize the output, we run configurations, and then we say, hey, you have 56% for complexity, we organize everything for you, and it's just static analysis, in our opinion, done well. And yeah, so this is my presentation. This is my email and my Twitter account, my GitHub. Please do contact us. We just want to engage in these discussions. So, thank you.
Great, thank you very much. So a couple final announcements. Once again, thank you to Constant Contact for hosting us and setting us up with this great venue and the delicious pizza. There's still plenty of pizza over there, it looks like, so please grab some. And a couple plugs for, so this is, like I said, part of a national series. We actually have both a blog and a Twitter called Autotest Central. I had a slide with the URLs and everything, but it wasn't working properly. So autotestcentral.com. We have a blog there. This video, we've been recording it, so that'll go up there. And then the Twitter as well is the central hub for all of the different meetups around the country. You can get information about all of them if you happen to be in New York for one of them and you want to go. On top of that, I think that's about it. So
we're hiring.
Oh yeah. So Solana Labs, the company that I work for, plug. We are currently hiring. We're looking for a lead developer, a front-end engineer, and also a site reliability engineer. So if you are looking for work in any of those positions, or you know somebody who is, please come talk to us because we would love to talk to you. Yes.
I'm also looking for somebody who's interested in static analysis and in functional languages like Haskell, Scala. Also, if you're interested.
Okay, great. So,
if you're interested in an opportunity to build a continuous integration stack from the ground up that'll be used every day,
Interesting. Okay.
great. With that, I think we're done. So thank you all for coming.